Hey guys, Mr. Prosky here. Hope you're having a good day so far. We are moving into chapter 12 today. We will I think we're just going to, let me just check something really quick. I know we're in the middle of a video, but we're going to have a few more sections here. I'm not sure yet if we're going to have any quizzes or anything, but this week, when this will be posted, the 22nd is the last day for work, and so we're going to try to get through probably 2 or 3 more lessons, but I'm not sure if we're going to have any more quizzes or not. Because this is like the last week for us to assign homework, I would really encourage you guys to make sure you complete your quizzes. If you are way behind and haven't completed anything, or very few things, just focus on getting the quizzes done, and then move into the most recent homework and trying to complete older homework too, okay? But we're moving into chapter 12 today, which is, name of the lesson is, ready, 1, 2, 3, explore solids. Essential question, ready, 1, 2, 3, what are the different types of solid figures? So it's chapter 12, which will be our last chapter we're going to cover. Yay, you guys made it. Pretty awesome. It's going to be solids. And so solids are basically just, they're like three-dimensional shapes. So there's spheres. So down here, there's a whole bunch of solids. Polyhedra, prisms, pyramids, prisms, pyramids, cylinders, cones, spheres. Those are all types of solids. You could also have like kind of, I don't know if you guys have drawn those cubes before, like this, right? That is a solid. That's a solid. A cube is a solid. Okay. So those are the things we're talking about today, and we were working with area in chapter 11. We're working with volume and surface area for this chapter. Okay. This will be the last sections we're going to be covering this year. So really good job, and I hope you guys are feeling really proud of yourselves. Pat yourselves on the back for getting through all this. So let's get into 12.1, which is exploring solids. Basically, we're just going to be learning about the types of solids this chapter, and then we'll get into actual surface area and other stuff a little bit later, okay? So, polyhedron. Say polyhedron. Say polyhedra. So, a polyhedron is a solid that is bounded by polygons. Bounded by what? Polygons that enclose a single region of space. Okay? So basically, it's any like solid or three-dimensional shape that is like covered in polygons. There's no curves. There's no curved kind of shapes basically. Okay, and a regular polyhedron is a polyhedron whose faces are all congruent regular polygons. Okay, another name for regular polyhedron is platonic solid. I think it refers to Plato. I could be wrong on that. I'm pretty sure it's referring to Plato. But a cube is a platonic solid or regular polyhedron because a cube is made up of all what kind of shapes? What are all these shapes that I'm drawing here? Those are all this right here, this right here, this right here, the back, the bottom. Those are all squares. So that's what a platonic solid is. It's basically a shape that has all the same kind of, like polygons on each of the sides. There's also, I don't know if you guys have seen, like, the Dungeons and Dragons dice. Like, that's really bad drawing, but there's, like, the dice that have, like, 4 sides, and there's dice that have 20 sides and 12 sides, and 6-sided die is like a cube, but, all those different types of shapes are platonic solids, which means they all have like the same polygon in every face. Whereas something like this right here, see how we have a rectangle right here, and we have a triangle right here, that would not be a regular polyhedron or a platonic solid because it has different shapes. Alright? And then the different types of solids. We have polyhedra, which have all polygons on every single face. And this one is not a polyhedra, these ones over here, and that's because we have, is a circle a polygon? Do you guys remember what makes something a polygon? A polygon has no curves. Does this have curves? No sections. And there was something else too. There's something else too, but those are the ones that matter for this one here. Basically, there's no curves in a It's going to bother me. I don't remember what the third one is. But anyways, these are not polyhedra because they do not have, they have curves. All right. But they are solid still. So this is a cylinder, just like a can of soda or something. And this is a cone. All right. A cone is like a curved kind of pyramid. We have pyramids over here. Oops. Where's my eraser? So yeah, we have a pyramid. A pyramid is going to... So here's the difference between a prism. This is called a prism right here. This is a prism. This is a pyramid. All right? A prism is going to have two bases that are going to be... Let me see if we're going to cover those later. We'll cover those in a little while here. I'm going to come back to this in a little bit here, okay? Sorry, I'm all over the place right now. So, a convex polyhedron is a polyhedron such that any 2 points on its surface can be connected by a line segment that lies entirely inside. Lies entirely what? Inside or on the polyhedron. Remember, what does convex mean? There's convex and concave. Which one had dents? Do you guys remember? Concave had dents, so convex means no dents. All right? Okay. So we're going to come back to the prism and pyramid and stuff in a little bit here, but I want to make sure we cover the actual parts of the polyhedron before we come back to that. So we're going to go down to this. So actually, we'll leave it like that. Face. The face of a polyhedron is the polygons. The what? The polygons of a polyhedron. And basically the faces are all the flat parts. All the flat parts of the polyhedron are the faces or polygons. All right? An edge is a line segment formed by the intersection, by the what? Intersection of two faces. And those are going to be the lines. You guys know, like the edge of a table is going to be like the corner, like the edge that's like the flat part, the little line on the table, basically, right? A vertex is a point. Oops. A point. A what? A point where three or more edges meet. Another way to think about that is it's the corners. And a base is a polygon that is used to name. Used to what? Used to name the polyhedron. All right. So, we're going back up to the top over here now, okay? So, a prism, say prism, say pyramid, okay, say sphere, okay, say cylinder, say cone. I'm sure you guys said every one of those out loud because I really know you guys you're saying that out loud in your house right now. Anyways, so a prism, here's what makes something a prism. Sounds like prison, but a prism has two polygon bases. We're gonna put parallel in here. Dang it. Two parallel polygon bases. All right, and a pyramid. A pyramid, it ends in a point with one polygon base. Okay? So a prism is two polygon bases that are parallel, and the rest are going to be like rectangles or squares usually. And a pyramid is going to end in a point with one polygon base. So let's zoom into the prism here a little bit. I'll zoom in a little bit here. So the prism, you can see which two bases are parallel to each other. Can you guys see which of these are, like right now, this side's is going to intersect this side right here. So those aren't parallel. Which ones are the parallel ones? Top, bottom, left, right? Hopefully you said top, bottom. Do you guys see these two triangles? The top and bottom? Those are the polygon bases, and they are parallel because they do not intersect each other. They're in like a three-dimensional space like this and like this, right? Okay, so that makes something a prism, and you can see for the prism, the rest of the sides are like rectangles. So you guys see this, and then in the front we have a rectangle. Okay, Let me highlight those polygon bases again. And so basically this would be a triangular prism. We name the prism based on what the bases are. This is a triangular prism. Okay, because the triangles are the bases, which are the two parallel sides. A pyramid ends in a point. Right up here, you can see the points right there. And it has one polygon base. And the base is going to be opposites of the point. Okay? So this would be what this is going to be called. You can see the rest of the sides. The rest of the sides are going to be like triangles. And then we have this one over here. Let me highlight that in pink again. This would be called, it's not just a pyramid, this is going to be called, what's the shape of this base down here? What shape is that? This is a square pyramid. Okay, it's a square pyramid. So basically the bases are the parallel sides or the sides that are opposite of the points in a pyramid, and then that's going to name what the shape is, okay? So this is a triangular prism because the bases are triangles. This is a square pyramid because the base is a square. Okay? So why don't we go ahead and try a couple of these examples here, and we will be good to go. So for A, make sure I got everything here, okay? So it says, tell whether the solid is a polyhedron, which means all polygons, no curves or anything. And then if it is, name the polyhedron and find the number of faces, vertices, and edges. Okay. So let's see here. Is shape A? Is that a polyhedron? What do you guys think? Are there any curves or any sections in this polyhedron or in this solid? No, there's not. This is going to be yes. Okay. Yeah, it's really bothering me. I can't think of the third thing here. I feel like that was a big fail on my part. No curves, no sections, and all connected. That was the third thing. Going back up here. Sorry. It just really bothered me. I couldn't think of that last thing here. All connected. I'm pretty sure that was the last thing. Okay, basically a polygon needs to be no curves like these. It needs to be no sections. It can't be like a polygon can't be like this. And it has to be all connected. It can't be like that. Okay? So those are polygons. All right, so this is going to be, yes, this is a polyhedron because every single shape, we have a triangle, we have a triangle, we have a triangle. Those are all polygons, right? They're all connected, there are no curves, and they all are no sections. So it's a polyhedron, and now we need to name the polyhedron. So looks like we have a point up here. So which of these shapes up here had a point? Looks like we have a cone to choose from and a pyramid. Which one do you think we're working with here? Does it have any curves or no? It does not have any curves. This is going to be a pyramid, and then what's the shape opposite the point in the base here? What shape does that make? This is a triangular. Oh, sloppy. This is a triangular pyramid. Okay? Triangular pyramid because it meets at a point at the top, and the base opposite the point is going to be a triangle. Triangular pyramid. Boom. All right, now we need to name the number of faces, vertices, and edges. Let's use different colors for each of these. So for the faces are all the polygons that we see. How many like flat sides do you see here, okay? I see one on this, like the side most facing us, like toward the front. I see one on this side over here. Do you guys see any other faces? There's one on the back side over here. That's another face, the third side. And we have one on the bottom here, which is going to be 4. So we're going to have 4 faces. All right. Let's use black. All right, vertices. Vertices are all the corners. How many corners do we have here? I see one at the top. I see another corner down here, another corner down here, another corner down there. So we're going to have 4 vertices. Let's use orange. I'm picking like the worst colors, but deal with it, whatever. Edges are kind of the hardest ones to see, but those are going to be all of the all the edges. The edges is going to be the lines. So we have, how many lines here? We got one line there. We got a line for every face of every polygon. So there's 3. We got 4, 5, and 6. So it's it's a triangular pyramid, and there's going to be 4 faces, 4 vertices, and edges. 4 flat sides, 4 corners, and 6 lines. All right? Kind of tricky, but same kind of process here. All right, let's look at B. Let's use red. All right, we need to determine whether it's a polyhedron. So, are all the sides of this shape, are they all polygons? Are they all polygons? These are all, there's no curves, there's no sections, and they're all connected, so this is going to be yes. And then which of these is the bases? Will you guys find the bases on here? I could see, are these the bases like this right here? And it doesn't matter if they're sideways. You can have the bases be sideways, but are these the bases? They are parallel, but that's not usually the... Another thing I forgot to mention is that you want to have usually in polyhedrons, the sides are going to be rectangles or squares. I think I did mention that, but usually if you... Like, these could technically be bases because they're like parallel to each other, but you want to look for the most unique polygon in this shape here. What's the most unique polygon you see up here? Can you guys see it? What is this shape right up here? How many sides? 1, 2, 3, 4, 5, 6. What kind of polygon has 6 sides? I'll keep those actually. It's going to be a hexagon. So this, and then we have on the bottom here, we also have this hexagon. So it looks like we have 2 bases that are parallel to each other, and they are hexagon in shape. So is this a polyhedron? Are these all polygons? It is yes, they are all polygons, and it is a polyhedron. Now, what kind of shape is this? Is this a prism? Is it a pyramid? Is it a cylinder, cone, sphere? It's going to be a prism because we have 2 parallel sides, or 2 parallel bases that are both hexagons. This is a hexagonal or hexagonal. I'm not sure exactly how you want to say that, but hexagonal prism. Okay, it's a hexagonal prism. All right. Okay, let's cruise a little bit. So, next thing we need to find is the faces. So we already have, these are the 2 faces there. And if I can give you a hint for working with faces, guys, if you have a prism, you're going to have the 2 parallel bases are going to be 2 faces, and then we're going to have a base for every side of the base. So how many sides do we have in the bases there? We have 6 sides. So we're going to have 1, 2, 3, 4, 5, 6 going around all around here are all going to each have a side. So this is going to have we're going to have the two bases are going to be faces, and then we're going to have the 6 sides on the sides. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. We're going to have 8 faces. Okay, let me go over that again really quickly. Okay, if you're working with a polyhedron or with a prism, you're going to have 2 parallel bases. Those are going to be faces. And then looking at the sides, so looking over here at this prism, we have this and this are both 2 faces. And we also have a face here, here, and here. So we're going to have 1, 2, 3, 4, 5. This one's going to have 5 faces because it's going to have basically a face, each of the... each of the bases are going to be faces, and then also each of the sides of the base are also going to be faces, okay? That was a little clunky, but hopefully that makes sense. Otherwise, you can just count the flat sides. Let me just clean this up a little bit. That red. Okay, you can just count them in green. So we got top, bottom, front, right, back, back left, top, front left. So we got, 1, 2, 3, 4, 5, 6, 7, 8. So there's going to be 8 faces, 8 flat sides. Okay, let's not make it more complicated than it needs to be, but I'm trying to give you a shortcut. Okay, and then we have, I erased prism there. All right, next thing we're working with are the vertices, the corners. Okay, here's another thing for corners. The corners are going to be, we're going to have corners at each of the edges of the bases. So we have 1, 2, 3, 4, 5, 6 of those. And we're also going to have, so 6, 7, 8, 9, 10, 11, 12. So you're going to have a corner at each of where the bases, where the sides intersect. Where the sides intersect here. All right? And then the edges. Edges is a little bit trickier. So we're going to have an edge for, we're going to have double the edges of the bases here. So we have 6 edges there. We have 6 on the bottom. And we're also going to have more on the top. So we have 12. We have 13, 14, 15, 16, 17, 18. Okay? So sorry if that was a little bit more complex than I wanted it to be. You can just count for the faces, just count the flat sides. For vertices, just count the corners. Edges, just count the lines. Okay? Let's not make it more complicated than it is. I'm sorry if I did. All right, next thing. Is this a polyhedron over here? We need all polygons for all the faces. You guys see any curves or sections or non-connected parts? I see a curve right here, so this is going to be no. And that's all you got to do. If there's not a polyhedron, you don't have to find all the other stuff because there's curves. All right? Why don't you guys, I'm going to leave it right here. Why don't you guys go ahead and pause the video and try checkpoints 1, 2, and 3. All right, welcome back. We're going to go through this a little bit quicker. So, tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of sides, vertices, and edges. Okay, is this a polyhedron? I think these are all polygons. This is going to be yes. And then what are the bases of this, or what kind of shape is this here? You guys see any bases? So obviously, and then another thing you're gonna exclude. You're gonna exclude all these if you see any flat sides there. We're gonna exclude all the curved ones. So it's either gonna be a pyramid or it's gonna be a prism. Ooh, went too far. This is gonna be a prism because we have the bases are these are what kind of shapes? These are pentagons. So this is a pentagonal or pentagonal prism. Pentagonal prism. All right. Now, how many faces do we have? Should have gotten 7 for that. Okay, 1, 2, and then each one of the sides. Okay, all the flat sides there. 7 faces. We should have 10 corners. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Makes sense. And then we're going to have how many edges? We should have had 15 edges if you counted them correctly. All right. Okay, next one. Is this a polyhedron? Always look for curves first. Are there any curves here? I see curves right here. So this is going to be no. We don't need to do any more. We're done with it. All right. Last one. What kind of shape is this? Are there any curves or anything? Is it a polyhedron? Does it have any curves? This is a yes, because there's no curves. They're all polygons. And looks like it ends in a point, so it's going to be some type of pyramid. And then what's the base of this called? What shape is that right there? That's a rectangle, so it's going to be a rectangular pyramid. And then we're going to go a little bit quicker here. You should have gotten 5, 5, and 8 if you did this correctly. Okay? Count. This is the flat sides. This is the corners. This is the edges. All right? Moving on. Euler's theorem. Say Euler. It says Euler, but it's pronounced Euler. I promise I'm not telling you the wrong thing to tell all my friends that I made you learn something goofy here, okay? It's Euler's theorem. This is a theorem to help you calculate faces, vertices, and edges given a formula, all right? So, the formula for, let's use the fun colors over here. The formula for Euler's theorem, the number of faces, vertices, and edges of a polyhedron are related by the formula faces plus vertices equals edges plus 2. Okay, so this is kind of a shortcut. So we are going to find the number. This one says find the number of faces, vertices, and edges of the polyhedron shown. So what we're going to do for this weird shape over here, the formula is the faces plus the vertices equals edges plus 2. So we are going to count up all the faces and all the flat sides and all the corners, and that will tell it. Then we can figure out the number of edges using this formula here, okay? So how many flat sides do we have here? I have the front and back, and then I have the bottom. I'm just going to kind of go around here. So we're going to go front and back, 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 faces here. You can recount those again if you want. Okay. There are 8 flat sides. And then how many corners do we have here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we can find the number of edges. Counting edges in weird shapes like this takes a long time. So here's kind of a shortcut using this formula here. We're going to do faces plus vertices equals edges plus 2. So faces was 8 plus 12 vertices equals edges plus 2. All right, that's 8 plus 12 equals edges plus 2. And how do we solve for E now? We subtract 2, and then we're going to have E is going to equal 20 minus 2 is 18. Okay? So it's a shortcut. All right, almost done here. Making good time. All right, is it possible for a polyhedron to have 16 faces, 34 vertices, and 50 edges? Explain. Well, we're just going to plug this into the formula and see if it's true or not. If it's not true, it doesn't work. Because it's got to work for every polyhedron has that formula. It should work for them. Faces plus vertices equals edges plus 2. So we had 16 faces. Oops, I put equals there. Faces is 16 plus 34 vertices equals 50 plus 2. What's 16 plus 34? That is 50. And 50 plus 2 is 52. Does 50 equal 52? So it's no. If it's going to be a polyhedron, it needs to fit that formula, and it doesn't fit the formula. All right, last thing we're going to do here, cross sections is the intersection of a plane and a solid. Of a what? Plane and a solid. Okay, so to determine the shape of the intersection of the plane and the solid. So basically we have this plane right here, which is just like a flat two-dimensional shape, and we're going to look at the shadow part where these intersect. So what shape did I circle there? If you said an oval, that's true, but you got to think about looking at this from the top, and it's actually going to be a circle because the whole thing is a sphere. The shape that it makes this that cuts this through this solid, the sphere, is going to make a circle. All right. What's the shape of this middle one over here? Looks like we have 5 sides. What's the 5-sided shape called? It's called a pentagon. All right, and this one's kind of weird. We have a plane cutting through a cylinder, and it looks like we have this shape right here. What's this shape right here? It's going to be a rectangle. Okay, a lot of this is just really visualizing. It's kind of hard for some people to visualize the corners and the, faces and everything, but it just takes a little bit of practice. You guys will be okay. All right, why don't you guys go ahead and do checkpoints 5, 6, and 7 really quick. All right, welcome back. Looks like we have this shape right here where it intercepts, and that's going to be a rectangle again. What is this shape right here where it intercepts the prism? That's going to be a pentagon. Oh, wait. Yeah, it's a pentagon. Duh, sorry. And the last shape is kind of weird. It's at an angle. It's going to make this shape right here, which is a what? It's a triangle. Okay, I think that's the end of the lesson. Thank you guys for watching. Sorry it was a little clunky today. It's been a long day, and appreciate you guys sticking with it. If you have questions, make sure you turn in your homework on time so I can give you feedback. And it hopefully shouldn't be too hard of an assignment for you. Thanks for watching. Have a great day, and we will see you soon.